All right. Hello, everyone. Just doing another video here on error handling and exception handling for CPSC 1012. The objectives of today's video, we're going to explain the differences between errors and exceptions, and we're going to explain and implement defensive programming. So I'll give you an idea of what that looks like and why we might want to do it. And then finally, we'll implement try-catch exception handling in our programs, which will enable us to recover from those unexpected encounters of invalid input that you may have just accidentally already seen in your own programs when you're prompting for a particular type of input data and you get another kind. We'll look at how to deal with that in today's lesson as well. So without further ado, let's get it. Okay, the program I'm going to use to cover these topics is a program from an earlier lecture, a lesson 3 loops solution. And I've cut back the preconditioned solution piece from that lecture. So we're just dealing with the solution as it was implemented with a post-condition do while. And I've included a couple of additional comments in the code just to give us an idea where we might want to look at some issues that could arise in the program and how we can implement some solutions. And then as well in the planning document, I've included a couple of very basic, simple test runs that we can implement to go through and test our program. So before we go into the implementation of the actual exception and error handling, I want to run through a couple of iterations of the program just to show you exactly what are some of the issues that we're going to try to address and why it's important to address them. To this point, we've assumed in your programs that the user will always enter valid and correct data. But as I'm sure you know from experience, and perhaps even you yourself running your own programs, that's not always the case. Sometimes you'll just slip on the keyboard or hit the enter key too soon or who knows what, and you enter something that is not what's expected, and the program effectively crashes or experiences what we call a runtime exception, right? There's something that happened at runtime that we didn't plan for in advance, it couldn't be known in advance, but it's caused the program to crash. And that obviously is not good for user experience, and it's something that we want to address. So coming back to the program here, the one thing we want to keep in mind is there are certain aspects of the code and the program that we have complete control over. So the declaration of variables, assignment of good values, display statements to the console, those are all things that we know we can code and they should work. I'm not expecting anything strange. They should do the same thing and have the same effect each and every time that we execute the program. But where things can get a little bit crazy is where we don't have control over what's happening. And those are the pieces in your code and in your program planning that you're going to want to zero in on and really think hard about, because those are the areas where an outside influence can have an effect on the execution of your program. So for example, looking at our current solution, if we go down into our loop body, we've got a piece of code here that goes to the console and reads in some data from outside. So this is kind of what I was talking about. It's almost like a hole in your program where everything is nice and self-contained, but for this particular method call. So when we go to the console and read something in, and specifically we try to parse that input into an int, we don't know what that value is going to be. Okay? Here I know this is always 0. We don't know that the user is going to enter in a good value that can be parsed to an int. So this is a place of concern for us. Likewise, if we go through this solution, let's say in the first case, and the user chooses to not enter any values, we're straight away trying to do a division here in this line 33 expression, and dividing by 0 is a problem, and we're presently not accounting for that. We're assuming that the user will enter in at least one good value, but maybe they don't. It's entirely possible, okay? And those are two examples of two different types of problem, okay? They both can cause exceptions, but one of them we have control over, where the other one we don't. And this is where the difference between defensive programming and exception handling comes into play. But let's see it play out first in a couple of sample runs. Okay, so here's, we're asking for input. Here's an example of the first case. So let's say we enter in a 0 straight away, and now we've got this problem, right? Execution stops because we're in debug mode, but we can clearly see there's some kind of an exception or an error that's happened at runtime here on this line in our code, right? And the reason for that is that these values are not, they're not going to work. And it tells us down here below, I've got a system divide by 0 exception, right? Attempted to divide by 0. That's not something that the computer can do. And when it encounters that, it's going to crash the program, just like what we've seen here. So it's the statement is fine. There's nothing wrong with our syntax. The problem arises at runtime, given the fact that we haven't accounted for the possibility of this particular variable being a 0. Now, we could deal with that as an exception, but because we know the types here and the values that they should be, this is something that we can easily deal with a very simple if-else statement, right? We can simply just defensively program, right, code for those types of conditions, and without having to worry about this exception ever occurring, we can prevent it, right? We can easily ask if the count is not 0, okay, then great, then we should be able to do this. Or rather, we could say if the count is 0, then we know that, again, we can't. Maybe we display some kind of a message that says, couldn't do this operation or something like that. So that's a case where we can use defensive programming. We don't need to catch this exception. We could, but we can easily ask questions about the count. We know that it was initialized to 0, so that's a known thing. We can walk through our code and see that the only options for count are that it has a valid non-zero value or it has a 0 value. And so we can simply use a decision and we can deal with that. No need to deal with exceptions. Okay, so that's, oops, let's go back there. There's no need to kind of deal with this. I'm just going to stop the program in its tracks and we'll check out the other case. So that's one problem, right? We just go through, we don't enter anything. We have a divide by 0 issue here. The other problem that we'll have is when the user does not give us what we're looking for. So we're asking for a positive value or an integer, no less, and they type in some string of characters that cannot be parsed as an integer. And so you'll see here again in debugging mode, it stops. We've encountered a system format exception where the input string was, it says here, can I get rid of this? There we go. Not in the correct format. So we're trying to int parse, but the value that was returned by the console.read line is not in a format that is compatible with this method, and that crashes our program. Okay, now this is different than the count is equal to 0 issue because we don't have control over that, right? We don't know what the user is going to enter here, right? They might enter in ABC, they might just hit enter and enter nothing. They might give us a good whole value, but we don't know. So this is a case where it's not possible to defensively program. We need to be able to deal with the exception if it occurs at runtime. And that's where the try-catch exception handling can be used in this program. There's also another method that you might see if you do some searching online called try-parse, but I'm going to just stick to the try-catch because that's useful in many different situations and is kind of at the core of exception handling. Try parse in the future if you want to use it, I'm fine with, but for this lecture or this lesson, I just want to stick to the try-catch solution. So let's stop that, and by the end of this little lecture, we're going to have solutions in place that address both of those. Again, you can see here by my comments, these are the things that we're going to try to deal with. Terminate. So let's go back to our planning document quickly, and I just want to show you a very simple test run scenario that we can use to test this. So our input variable value is the only input that we have, and there are a couple of cases that we want to use to test for these particular scenarios. Okay, and one of them is the negative input value. Right now, if the user enters in a negative value, we're not dealing with that. Okay, again, that's not going to cause a problem per se, but it is going to lead to a logical error. So our program isn't going to crash if we enter negative values, but it's not going to give us correct or valid values. So that's something that we want to address. Right now, we just have a condition that says, if the value is not equal to 0, then do this. But if the user enters in -10, -10 is not equal to 0, so we're going to subtract 10 from the sum, and we're going to increment the count, which isn't accurate. We don't want to do that. The division is going to work because, -10 divided by 1 is fine. It's going to show us the average is -10. So nothing is going to crash our program in that case, but it's not a valid result. So a -1 is something where if I enter that, I do actually want to see an error message. I would not expect to have an average calculated or to be reprompted without seeing something like this first. So I would expect some kind of an error message to be displayed, okay? And so we enter -1, I would expect to see an error message and then be reprompted, and then entering a 0 straight away to deal with this issue. If we have not entered a valid number, entering a -1 followed by a 0, I would expect not to see the average of the values as X. I would expect to see some kind of a message that says there is no average to be calculated. We didn't enter any numbers, so there's no average, okay? So that's our first test run. The second test run, again, entering values for the variable value, right? If we entered in this string ABC, this would be a test for our exception handling. Again, I would expect to see some kind of an error message and then be allowed to continue. And then following with the example input that I used in the previous video, if I entered a 40 followed by a 30 and then a 0, I would then expect to see a valid average of 20 to be displayed. So these are just 2 sample test runs that we can use to run through our code to give us a little bit more confidence in the validity of our solution. Again, with testing, you might never be able to do 100% of all the cases in terms of test coverage, but learning to know where to look and how to write some good test cases is going to be helpful, and at least getting us closer to that place where we can say with some confidence, I think the program is going to work under most conditions. So with that in mind, let's start thinking about how we can address these issues, and we'll start with the first bit, which is our first test run, the -1 input. So at the moment, we're running through, we're declaring variables, we display a program title, then we're going to ask the user to enter an age 0 to end. And the only conditional check, let me zoom in here, the only conditional check we have is if the value is not equal to 0. But that's not all we care about, because if the value is not equal to 0, great, do this. But I also care that if the value is less than 0, I want to be able to display some kind of a message. And that's not what's being accounted for. So we can do that simply with some defensive programming logic where we, again, just add another condition. So before we determine whether or not we want to do something, we need to know what valid inputs are and what invalid inputs are. And so for the purposes of this program, we're being asked to enter positive values or 0 to enter, okay? So 0 itself is a valid input value, okay? A positive value is also a valid input value. It is only negative values that are invalid. So we can do a check first for whether or not the value was invalid, okay? And then if it was valid, then we can ask the question of, okay, well, was it not 0? Presently, if they enter in a 0, we're not doing anything. If they enter 0, we skip over these statements and we just exit. So we really only care about the case that it was less than 0 or that it is not equal to 0, which is accounted for here. So we can tie those together by including an additional if. So we can ask the question or state the condition. If the value is less than 0, then we can display some kind of an error message. So we might say something like display, enter a positive whole number, okay, as an example. Okay, so simple, very simple error message. It gets the point across, oh, I've entered in something that's negative. I can only enter positive whole numbers. And we need to tie these conditions together, because then if we didn't have the else here, if these were 2 separate if statements, if I entered a negative value, it would display this message, but then a negative value is also not equal to 0. So then we would continue to do these. I don't want to do this if the value is 0. So we need to combine these into 2 logical flows or alternate flows that either one of those could happen, okay? Or none of them happens, as it were, if we enter in a 0. So we need to tie those together, and we can do that by turning this into an else if. So if the value is less than 0, we show them an error message, and that's it. We jump out of this structure because this is now tied together. Well, that was true, so we don't do any of this stuff. We go down to the value. Whatever the value was previously, we loop around, and we go ahead and we do the same thing, okay? So now this is a problem here. You know, in the future, we'll talk about why, but a negative value, if that's what we entered, is not equal to 0, so it will loop around and we'll be able to enter another value. Fantastic. If we do enter a 0, then 0 is not less than, 0 is in fact equal to, so that's not true. We just jump out and we get to our same old problem which we had before, which is, hey, you're going to get a divide by 0. So that's what this second input in the test run is going to check for. But this if then else right here, that should account for the -1. So we enter a -1, -1 is less than 0. I would expect to see an error message. Here it is, okay? And then we should be able to be reprompted and enter a 0 again. And when I enter this 0, I expect to see below here not the average of values is average. I would expect to see that we could not calculate an average. And so now we're moving on to dealing with this piece, which has to happen down below. And again, we can do that very simply by checking what the value of the count is. If the count is equal to 0, then we don't have an average. We can't calculate it, okay? Or if it is not equal to 0, then we can calculate it. Either way, it doesn't matter. So we're going to now show one of two final messages to the user. Either we're going to show that this is the average of the values that were entered, or we're going to show that no average could be displayed or calculated. And so now we have an if-else structure. There's one of two alternate flows, never both, right? We are going to do one or the other. And so that's how we can deal with this divide by 0 issue. So down below here, when we do the set average equals, we don't want to just blindly do set average equals to this. We want to surround that again in a check. So if, again here, the count is positive, if it's greater than 0, then we can do these things, okay? And else, if it's not, then we want to display the message, something like no average could be calculated, okay, or something like that. Oops. And if, okay? So if the count is greater than 0, then we can calculate it. Let's also wrap up this display because we just mentioned that can only happen in 1. So we have a count, calculate the average, display it. Otherwise, we tell the user, sorry, we couldn't display. So the no average message should occur if we go through this run through. So with these two additional checks in place, we should be able to go through this test run and see how we're doing. So let's give that an implementation and give it a run. So let's make the updates, right? The first is here. We have an additional check. If the value is less than 0, then we're going to display a message. So console write line. Let's do a blank line so we have some separation. And then we can do our message here. Enter a positive whole number. We'll be very explicit about what it is that we're expecting. Okay, so that's the error message. And then it's not just another if, it's else. So the value wasn't less than 0. Well, was it not equal to 0? Because if that's true, it was positive and we want to do these two steps. And then if it was 0, there's no else required because we're not actively doing anything if the value was a 0, right? We're just ending, we're just leaving it. So that's the only conditional check that we need to include for this particular error message. As we've gone through our plan, we've implemented it here. And then finally, we can do the same thing down below. So to deal with this divide by 0 issue, we can ask the same question. So if, in this example, the count is greater than 0, then we can calculate the average. And we can display the message to say, hey, this is the the average. Else, we know that we don't have an average to display, so we can go to the console, we can do a write line, and I'm missing something. What am I missing? Something fell apart here. Is it just this? There we go. So else console write line, and we'll display our message something like no average could be calculated. Okay, or we could say no values were entered, or something like that. Okay, so then we'll say that hopefully should take care of this. So with those two additions, we should now be able to go through our test run and see exactly how this is going to work out for us. So let's give our program a run and see if we've adequately addressed those issues. So in the first case, we enter at a -1 value. Perfect. We see our message, error message, and we get reprompted to input our second value. If we put a 0 in here, we see a message that says no average could be calculated, and then the program ends. So this test run is successful, right? We've implemented the changes. We got our error message. We got our no average message. Awesome. Test run 1 is good to go. Okay, so take a moment to think about those changes. Think about how we identified them. Again, these very simple test runs are quite useful if you can, in advance, identify the issues that you want to deal with and think about the input values and the order in which you want to input them to produce the desired, or in this case, undesired results, right? And that's part of problem solving, is identifying the little issues that might crop up in your programs and then trying to think of solutions to those problems. So, you know, the general problem of write a program to calculate an average of numbers is one thing. And now within that problem, we've got these smaller problems that we need to deal with. Well, what if we don't get the right input? What if we get no input, right? What if we get, you know, it's a valid number, but it's not in the right range? We have to start looking for those smaller problems within the problem and how we're going to address those. Okay, so that takes care of the first part. We've solved those issues with defensive programming. No exception handling has happened here. We've just used basic logic and problem solving and coding to make sure that we don't run into those logical errors or syntax runtime errors. So in the second case now, the test run 2, we're explicitly going to be dealing with the exception issue. Okay, so this is a little bit different. Here, we are not getting something that we can handle within our program with defensive code. We need to be dealing with exception handling in this example. Okay, and so the only place where the input would come in for us to deal with that at this point in time, again, is here on this statement here, line 22. Specifically the int parse method. It is this method that could potentially throw the exception. And you'll see that if you hover over it, we get in the fly up here, it tells us there are exceptions that can come out of this, right? Things that you might want to consider. Argument null exception, so we get nothing, a format exception, and then potential overflow exception depending on what kind of input goes in there. So these exceptions could all occur, and we know about it in advance. So there's really no excuse to not be prepared for that. Okay? The mechanism that we can use for exception handling within C# is called try and catch. Okay? And the idea there is we can try to execute this statement, and if there's an exception that occurs, we can catch that exception, and then we can deal with it so that we can keep our program executing. Okay? We're just going to deal with a generic exception catch in this example, and for the most part for the course. If you want to catch for specific exception types, you can, but that goes above and beyond the scope of what I'm interested in you being able to demonstrate to me, at least at this point in time. Catching a general exception for all of these three types is useful insofar as we can keep the program running, and also as a mechanism and an introduction to exception handling for you, so you don't have to worry about all of the different types of exceptions and how to do multiple catches and things like that. We're just going to deal with the one-off. Okay? So again, implementing a try-catch is pretty straightforward. It's not the code that's difficult to think about. It really is the logic about where do we want to do it and how do we deal with the exception if we were to catch one. Some people will look at the solution and say, well, the easiest way to catch an exception is to just try all of the code. But that's not going to work. We can't try to run all of this, because if there's an exception explicitly around the input, I want to be able to repeat the prompt. I don't want to catch the exception and then end the program and say, hey, you entered ABC. That's not valid. Program is over. That's not what we want. We want to be able to catch the exception, alert the user and say, hey, this is what I'm expecting, and then allow them to continue. So we've really got to kind of narrow in and think about, well, what is the minimal piece of code that we can deal with this exception in and still maintain the basic program flow? And here, it really is just this idea of prompting the user for input. So we're going to try to execute these statements. Again, whether you do it solely around this statement or you encapsulate both the prompt and the parse together is up to you. It's a matter of taste in some cases. I'm going to group these two together because logically that's my prompt. And so it will make it clear to anyone who's reading the code that I'm trying this prompt, and if there's an exception, then we'll have to deal with it. So the way that we can work with this is to surround these statements within a try block. Okay? So we use the keyword try, and then we begin a code block. So this now becomes code that we're going to try to execute. Again, I don't suspect we'll have any problems with this line, but this line, specifically this method call here, this is the one that I'm certain we could run into an issue with. Okay? So here we're trying this code. If any exception occurs within this block, immediately after, we can specify that we would like to catch. And within the parentheses, we need to specify what type of exception it is that we're looking to catch. So we noticed in the parse method, for example, there were 3 unique type of exception that could be thrown from that method. And we could choose to do something different depending on which of those 3 exceptions we caught. But again, for the purpose of this course, we're just going to catch the top level exception class, which encapsulates or covers all known types of exceptions. So no matter what type of exception happens, we're saying catch any of them with this generic exception. We give the exception a label. So I'm just going to label it E. If you wanted to label it exception or error, I mean, that's up to you. But the label here is really just what it sounds like. So for whatever exception has occurred, we can catch the exception, we say what the type is, and we give it a label so that if we wanted to, we could access the actual exception itself as an object, and then we could call methods or access properties of the exception to kind of tease out more information about the exception that happened. Now, as it is in this particular case, I'm not going to care too much about the exception message. I just know that if there was an exception that happened, it's likely because the user entered something that wasn't valid, and I just want to show them a message as such. So right now, this code is going to prevent our program from crashing, but you'll notice that here on line 31, I've got an issue with value. And it's saying, hey, look, you've got this unassigned local variable value. And the reason for that is if the first time we execute this program, the user enters in ABC, we're not going to assign value of a value. It's not going to be assigned a number because this failed. Okay, if the user entered ABC, there's no number to assign to value. Okay, and this is something very important to take away here is when an exception occurs, so if the exception is thrown from parse, this statement doesn't complete. It's right at that time where we type in ABC, parse fails, that the exception is thrown. Okay, we happen to catch the exception here. We do nothing, but that still leaves value, as it shows here, with no assigned number. Right? We never put anything in there, and so this check doesn't make any sense. It's like we don't know what's here. Like you've never assigned a value to this variable, so this is no good. We have to deal with it. So there are a couple of ways to go about doing this. In this particular example, we already have a solution that we can kind of piggyback on. right? We have a check here that if the value is less than 0, we're going to show a nice message to the user telling them exactly what we would like to see. We're not going to add the value to the sum or increment the count, and we're going to loop around and we're going to ask them to enter another value. So we can leverage this existing logic even if the user enters in something that's not a negative value, because the message tells us exactly what we want. If I enter a -10 or I enter an ABC, this message still tells me exactly what I need to know. Oh, I entered ABC. I should be entering a positive whole number. So if this same message can be used, what we can do in the catch block here is force our code to enter into this block, into this condition, and show the error message and then loop around. And the simplest way to do that is to just assign a negative value to our variable. Okay. Now, as soon as we do that, the error line goes away from here, because the computer knows, the compiler will know, that whether we try to assign the value here or we catch an exception and assign a value here, in either of these two cases, one of which is guaranteed to happen, value is assigned a good number. And so this isn't a problem anymore. We can do the comparison. So let's just walk through this quickly. If we prompt the user for input and they enter an ABC, an exception happens, we catch the exception, we put a -1 in the value variable, and then we check -1 is less than 0. So we display an error message. -1 is not equal to 0. We loop around and we reprompt the user. So we're able to take advantage of the pre-existing defensive code as a means to display an error message. Now, this is important. Keep this in mind. This isn't going to work in all scenarios. Okay? If we were asking the user for just numbers, positive or negative, then we wouldn't have this conditional check. So we wouldn't be able to utilize that. Okay? In that case, we'd have to display some kind of an error message probably here, and then think about how we want to deal with skipping over this chunk. It might be that we need to include all of this code alongside the try block. Okay, so every situation or scenario is going to be a little bit different, and you, again, need to really think about how it's going to work. And again, creating simple test run plans is going to be useful when it comes to testing your code and seeing that your implementation is going to work. This forces you, first of all, to think about what's important and how you're going to deal with it before you even get to the point where you're going to implement it in any kind of code. So let's save this. Okay, we've got our try and our catch block in place, and now we can give this a test run to see if we've captured everything that we need to. All right, so let's go ahead and run. Now, we've already seen this test run in action, so we expect to see something a little bit different. So we're going to enter in ABC. And sure enough, we no longer see that format exception. We've caught the exception. We set the value to -1. We've looped around, and now we're enter a positive whole number. Oh, okay. So now I'll enter in the 40. I'll enter in my 30, and then my 0. Again, it's important to follow your test plan, test run, because if we put in different values, then we're testing something entirely different. This is what I'm expecting. Given this input, we need to keep that same input. Okay, and so then finally, we'll put in our 0, and we see the average of values is 35. Okay, so that's my bad, because I'm telling you I'm putting these values in expecting to see an average of 20. But of course, if we put in 40 and 30, it should be 35. So make sure your test run aligns with your values. Again, here we're lucky because the testing values are pretty straightforward, but you get the idea. Okay? Even I can make mistakes. But what's important is without that test plan, I wouldn't know that I was making them. So this is all good. Everything runs. We no longer have issues, be it logical or at runtime, and we're able to deal with them. So again, what I recommend as good practice is to go back in time and revisit many of the programs you've already created to this point and see if you can't go back, revisit them, identify where exceptions could occur, and then try to implement some type of a try-catch or a defensive programming solution so that you can keep those programs running or at least exit gracefully. Okay? If you don't have a program with loops, let's say it's back to one of the conversion programs you've created. So maybe you're asking the user to enter a temperature in Celsius and convert that to Fahrenheit. Well, if the user enters in ABC, the better thing to do is not to crash the program, but to show an error message that says, sorry, could not complete the calculation, and then exit gracefully, right? But knowing what you know about loops, you could also go back and revisit those programs and implement a loop or a reprompt for those cases where the input is invalid as well. So there's lots of things that now that you know about loops and you know about exception and error handling, you can go back and revisit those programs and see if you can't improve them and improve the overall user experience. Okay, so that's something that we're going to expect going forward. So in your future assignments and labs that you're going to submit for work, and even in simple programs like this, I'm going to recommend, if not require you, to start thinking about and implementing exception and error handling and defensive programming to make you become a better programmer, and also forcing you to think about in advance, what types of plans are going to work to test for those cases. So hopefully you can start to see those issues before you even have to run them. Again, if you can deal with an exception before it goes into production, so you're able to find bugs before the user finds them, you're going to be in a better position, you're going to build more trust, and you're also going to feel more confident in your work, as well as any users or customers that you might have, they're going to feel really confident in having you work with them as well. All right, so that's it for this lecture. I hope you found it useful, and we'll see you next time.